Thank you. Good morning, everybody. Thank you all for coming. We're going to talk about application stacks today. And the reason why I think this talk is important is because the last 5 years have seen quite a change in what is the typical stack. But more than seeing a change in just the stack, we've seen a change in people's attitudes towards defining stacks, looking at what technologies they want to integrate, and how they think about the technologies they're using. My background, I was a co-founder of SpringSource, which was a fairly popular open source Java business that got sold to VMware in 2009. I've done quite a bit of open source contribution in Java on Spring and in RabbitMQ with Erlang, and spent a lot of my time between 2004 and 2010 looking at this problem from the outside, looking at what our customers were using for their stacks, looking at where they were headed, what they were changing. Basically spent 6 years of my life agonizing over this problem. And for the last 2 years, I'm back building an application now and faced this problem myself. What do we use in our stack? What technologies can we trust? What can we not trust? What's going to be changed in the next 4 or 5 years? And I think it's an interesting thing to talk about. So I want to talk about 5 things. I want to talk about traditional stacks. What are people using now, or what have we been using in the past? And what are the things, what are the changes in the industry that are changing the way the stack looks? What kind of movements or technologies or new practices are influencing these changes? The traditional world, I think, was quite boring and quite cookie cutter. There were a lot of people using kind of esoteric stacks and so on and so forth, but certainly in the Java world and certainly in the .NET world, there was a predefined technology stack. And it looked something like this. It was the traditional sort of 3-tier architecture, but within those tiers, what you used was very well defined. In Java, the presentation tier would have probably been the browser, occasionally maybe a Swing application or something like that, or certainly towards the end of this kind of generation, people were using the Eclipse toolkit to build their rich clients as well. The logic tier was almost always some kind of application server, some kind of Java EE application server. Towards the end, it was becoming Glassfish and JBoss. They were the big guys. In big enterprise, you would probably still see WebSphere or WebLogic, but that market got cannibalized by open source, and rightly so, I think, because that's just a commodity. And the database tier was, by and large, with very, very few exceptions, a traditional relational database, mostly Oracle. I spent a good portion of my career porting people off Sybase and SQL Server to Oracle for reasons that elude me to this day, for no discernible benefit other than spending of money and enriching Larry Ellison, it seems. And that was the stack. Very few people strayed from that. Perhaps the only interesting thing to mix in there would have been messaging, but even that was very cookie cutter. It would have been JMS, standard Java messaging from one of the big vendors, Tibco or IBM or something. Predominantly, it was Java and .NET. There obviously were people doing Ruby and Python, but no one, I think, can disagree that predominantly we were looking at Java and .NET. And I think it's fair to say predominantly Java too. Java EE did dominate for a long time, and still does, but the way that it's used is changing. Database vendors, for as long as I can remember, Oracle has dominated relational databases. We had many customers moving off Sybase. It just seems to have effectively dwindled into nothing now. I know there's a few people still using it, but they've not made a big business out of that. Microsoft has seen a real resurgence with SQL Server, I think. That's become a really good product. But all of these products still fit in that traditional category of relational databases. And even this is being cannibalized now. People like Postgres, which is getting more and more popular all the time. You see more and more vendors who are doing Postgres services. Particular one that comes to mind is Heroku with their fancy Postgres as a service. You can go on, get a Postgres database, they'll host it for you. You can fork it and all those kind of fancy GitHub verbs, that all works. So there's a big push away from the big databases. And I think you saw that when Oracle acquired MySQL. They recognized that those cheaper, lighter weight relational databases were cannibalizing their business and really cutting into what they were doing. That's the software side of things. That's the kind of the products that we used. Another important part of this was the big data center. And most of my customers had their own data center, and being on a consulting project, I quickly learned that what I had to do if I was going to do a contract was make sure they had the hardware available. It was no good scheduling to be in for a week's worth of consulting if we had to then wait 6 weeks for a machine. And it was one of the things that constantly surprised me was the level of bureaucracy and procedure and the amount of time people had to wait just to get a server. One of my customers was a big investment bank in London. They had an average wait of 6 weeks to get a machine, but they had an average cross data center utilization of less than 16%. Those two figures just don't make any sense to me at all, unless you mix into that big enterprise bureaucracy. And there was no collaboration between those two teams. They had almost had completely disjoint performance indicators. It was not in the interest of the data services team to serve the developers, nor was it in the interest of the developers to do what was needed for the data services guys. So it was a very, very strange situation. And you had these sysadmin teams who had an immense amount of power over developers, over what you could and couldn't do. And the same with DBAs. I've been in projects where the edicts come from on high. All database access must be via a stored procedure. And only the database administrators can tweak those stored procedures. And even seeing strange things like field names must be coded, so there's a code for the field name. It's not enough to have like address line 1. No. You'd have XB125, and that would then correspond in written documentation to address line 1. All these very strange practices. And I think all that's changed now. At around the time that we were doing the sale of SpringSource to VMware, this was all changing. And a lot of it at the time was changing based on this idea of virtualization. VMware obviously being a big provider of that, but also Citrix with Xen. A lot of our customers were excited about self-service data centers. The idea that they could have some magic portal by which a development team could go on and say, I want 6 machines, please, and they would do that. And this is now, I guess, called on-premise cloud, because self-service is not fancy enough. And that is something that is still progressing, but I just don't think has been delivered on. But it is definitely an important trend. And that leads me to talk a little bit about cloud. It's my opinion that cloud is one of the most important technologies in changing how people think about their stacks and how they think about building and deploying their applications. I have to say, I really just do not like the word cloud, because it is such an all-encompassing and broad term. I've even got my mum talking to me about the cloud because she's storing her files in Dropbox, which couldn't be any further away from people who are doing large-scale MapReduce jobs on Amazon's cloud or something like that. So it's this big, all-encompassing term. But when I talk about it in terms of enterprise developers or software developers, I'm really thinking about one main thing: the ability to create compute resources or other resources we need on demand and manage them via an API, putting the power in the hands of the developers. There are quite a few people who have started up cloud services. Amazon are obviously the big player in the marketplace, which I'm not sure anyone would have seen coming, that a bookseller would become the main provider of cloud services. But they do a very good job. I think their major strength, if you will, is their constant incremental improvement. They don't set the world alight all the time, but they do, almost like a juggernaut, inexorably move forward with their feature set and inexorably move forward with their performance. And their prices seem to go down. It is that unique mix of somebody who is used to working on very slim margins and on large volumes with somebody who has great technology infrastructure. Rackspace are obviously a really big provider as well, and a Joyent have a really, really interesting model because they have their own OS, their Solaris-based smart OS. The key thing is that there's a massive selection of services out there, and there are even vendors beyond this. The most likely way that people will get into working with the cloud as developers is through some kind of cloud compute service. This is the thing that is making those 6-week waits for machines disappear. You can go online and provision a machine with Amazon or with Joyent in a handful of minutes, and you can be up and running with it. And that can range from a very, very simple machine at Amazon where you've got maybe 600 meg of RAM, all the way up to something that's got 34 gigs of RAM and multiple processor cores, or even now you can provision machines with like dedicated GPU processing, so you can do fancy algorithms like that. The breadth of what you can achieve with the compute resource is phenomenal. And it has enabled lots of different changes. No longer do I have to wait for machines, but also no longer is it hard for someone to start up a new business or start up a service. And we've really seen that happen, is one guy in his bedroom now can build a nice little service and put it online because the cloud enables that. It isn't all roses, though. Compute is still not quite there, and there's still a lot of debate over whether or not virtualization is the great way to run things in production. Certainly, in terms of I/O, it can be quite unpredictable. But Amazon, in particular, have taken some steps to fix that. They have like dedicated I/O instances now where you can say, I want this many IOPS per second, and IOPS, and you can reserve that for yourself, so you can get much more predictable behavior now. Beyond compute, storage is probably the next interesting thing in cloud. And most people think of this really in terms of blob storage. I've got some data, I want to store it somewhere. Where can I put it? S3 at Amazon, cloud files at Rackspace. This has really, for me, changed quite a lot of the way I would think about some problems. My business is finance, so there's a lot of documents to store online for our customers, agreements, and so on and so forth. Traditionally, we probably would have stored them in the database in big binary columns just to make sure that it were part of our backup flow. Now we can store them in S3, geographically distribute them, encrypt them, and so on and so forth. But what I've seen recently is a real move away from just blob storage in the cloud towards other kinds of cloud storage. So relational databases in the cloud is a real and practical service right now. You've got Heroku, who are doing the Postgres, Amazon, who've got their RDS product, where you can get Oracle, MySQL, SQL Server. That works really, really well. More and more people are doing this. And then there are, beyond that, even more interesting things. Amazon have got their Dynamo product, which is a NoSQL style database that they offer for you. And they have this long-term storage where you can store your data on tape with them from a managed system that they call that Glacier. And it's really changed the mindset, I think, of developers that there's no need now to worry about long-term storage or data warehousing or all these things. You can get them for pennies an hour and use them kind of on demand as you need them. It's a real change. A long time ago, if I was doing a startup, I would not have expected to be able to access large-scale data warehousing hardware for a couple of $100 a month. But now you can do that. I would not have expected to be able to access simple, manageable tape storage that I didn't have to put things in a safe myself, but now you can access that. So this is having an impact on stacks by allowing us to take advantage of much more sophisticated technologies that traditionally have been reserved for larger applications in our smaller, simpler applications. And cloud is much more than this. There's so many more services you can get. Like, we've built an application that runs entirely on Amazon Cloud. The number of things that you can just push out to your provider is phenomenal. DNS, content distribution, messaging, alerting, monitoring, all of these things are available in the cloud. And that's just at the infrastructure level. Beyond that, and I think interestingly, there's this real push to have these kind of hybrid cloud structures where you've got some of your data on-site in your data center and some of it off-site in the cloud, or you're doing some of the processing off-site in the cloud. This is definitely an emerging area. It's still coming along, but I think it's going to be probably the typical architecture in the future where you can keep some core processing, core data on your own systems where you're not worried about data locality or any of those issues, and you can just burst scale in the cloud, kind of the holy grail that people are looking for. A lot of this infrastructure already exists. I'm not seeing a lot of people using it yet, but there's definitely a lot of interest, and a lot of vendors are trying very, very hard to get something meaningful into the market. This is all very interesting, and it's obviously great that we've got all these products, and great that we can use all these things, but how does it affect the stacks that we're building? How does it affect the applications we're building? Well, I think the first thing that people have realized, or certainly seems to that people have realized it again, is that architecting for failure is probably the sensible thing to do. Certainly, it seems that cloud resources are not as reliable as necessarily the resources in your own data center. So you're seeing a lot of architectures that would traditionally have been three-tier, quite closely coupled, moving towards much more loosely coupled, with the ability to take individual components out, not having the system die, and it's quite an interesting architectural decision. We took this in our business. Our origination system for all our incoming applications is completely decoupled from our servicing system. So we can take one offline without affecting the other completely. And in fact, within those systems, there are separate subsystems that can be taken offline completely. Traditionally, a system like that would not have been built that way. It would be one big monolith or maybe two big monoliths. But we're in the cloud. We have to assume that failure is going to happen. So we have to architect for that. This is seeing a lot more messaging usage, I think, a lot more REST usage, a lot more inter-component calls over some kind of bus. I think REST has really taken off as being a major player in doing this kind of architecture and enabling people to build systems that can cope with failure a lot more. This kind of cloud, this kind of infrastructure as a service cloud, is really just a traditional data center behind an API. That's really all it is. You get controlling over your networking. You basically get full control over everything, especially if you're using something like Amazon. What's interesting, I think, is for vendors that go beyond that and offer you a platform. You don't worry about how it's deployed. You don't worry about where it goes or anything like that. They give you a set architecture, and you just build your application. So Heroku is probably the poster child for this. They have this great platform where you just say, here's a WAR file, here's a Ruby application, here's a Python application, push into Git, go and deploy it. And they're taking care of everything behind the scenes. And that, I think, is definitely where cloud is going to head, where all of these things that we want, like databases, key value stores, messaging, will just be available kind of ephemerally in the cloud, and you'll just be able to hook into them with an application. You won't need to worry about how many instances have I fired up at Amazon, how many database instances have I fired up, where are they in the geography of my data center. You won't have to worry about that. So it's going to decouple you from thinking a lot more about what is underlying your application. I mean, Heroku could not be simpler, I don't think. It really is a 2-minute job to get something up and running on the internet. What I think is interesting about this and what's concerning and what is definitely a challenge in these spaces is how do you accommodate people whose application isn't just a simple monolith? So far, I haven't really seen a lot of these vendors working with multi-component applications that allow secure communication between those components. And I know that's something that certainly at VMware with their Cloud Foundry product, they're agonizing over that problem. I think cloud is still in its infancy, and there's obviously a lot of negativity towards cloud out there. Certainly, in the early days, performance was terrible on a lot of these providers, like dreadful. And definitely still predictability is a problem. You do get very unpredictable latency in I/O, very unpredictable load on the machines you're on, and it does really differ depending on where you are. What I am seeing, though, is people are kind of taking that on board, kind of embracing that chaos, and then learning to build applications around that. And Netflix is a great example of this. So they run their entire business on Amazon, on EC2. And their, I guess, kind of guiding mantra is to just assume chaos. They have this thing called the chaos monkey that in their environment just randomly kills things. So they're not waiting for it to happen. They're actively making it happen. And that is kind of the attitude to take in cloud, is that things are going to break, so don't wait for them to break. Make them break. And if your architecture is resilient to that, then great. You have to assume that you're going to lose things on a regular basis. So chaos monkey is a great idea. So I think cloud is a really good base technology. I think it enables an awful lot of things. But it isn't, I don't think, What's delivering the direct value to developers? I think it's the things that take advantage of cloud that are delivering the direct value. And probably the most, in fact, definitely the most exciting thing for me has been DevOps. 6 years ago, I did not get involved with ops. 5 years ago, I did not get involved with ops. Even 4 years ago, I did not get involved with ops at all. I ostensibly knew what was happening behind the curtain with the guys with the data center, but it just traditionally was not a thing that developers got involved with. You probably knew some Unix stuff, and you could probably do a deploy and things like that, but the magic of the production environment wasn't kind of apparent to you. And likewise, the ops guys didn't really get involved too much with finding out what the developers were doing, how they were instrumenting the code, where the diagnostics were, all those kind of things. It was very loosely based, probably around a handover of what the structure of your log file was. And I think DevOps is interesting for 2 reasons. One, definitely the increased focus on automation. I can definitely attribute most of the problems I've encountered in my career to not automating something that should have been automated. And now, whenever I look at a problem, should I automate this? Yes, because chances are I'll do it again. And I really do like the increased focus on automation that DevOps is bringing. However, I think that there's been too much focus on that, and DevOps has kind of become the term for just that, for just automation, and is ignoring the more important part, which is the increased focus on integrating operations and development teams together. It's really a delivery on the promise of Agile. These kind of cross-functional teams all working together, great. DevOps is a realization of that. It's saying, do you know what? It's not just important to have the business owner in the team. It's not just important to have the developer in the team and the project manager. We need to have the guys who are going to run it in the team. They can help say what the log file should look like. They can tell you what the output should be when there's a problem. They can tell you how they want to instrument and monitor and manage the software. You can discuss production environments with them. So it's not just a case of automation, it's a case of also integrating more closely with your team. And I think this is taking a lot of different forms. And probably the most important one is this integration into agile teams. I've not seen DevOps done particularly well in waterfall. Almost by definition, it can't happen in a waterfall environment because the ops stage is quite far down the line from where the development stage is. But in agile, if you're doing Scrum or Kanban or something like that already, and you're not getting ops involved with your project, that's something you should change. That is something you should definitely make a change on, because you can benefit almost immediately by having someone from your production team on your support team looking at what you're doing. Some people are going very far with this, involving vendors in their Scrum. If you've got someone who's doing managed hosting for you or looking after a database for you or whatever, you can involve them in your Scrum as well and get them on board with what it is you're doing. That can be quite a hard introduction. It can be quite a hard process to deal with, getting these people to do this. And I think this is why the focus has been on automation, because it's quite a quick win. A few machines start up and I can automate them, or I can automate my development machine or whatever. So if you're not doing automation with your DevOps stuff now, you really should be. And the landscape has really changed in the last few years. The number of things you can use now to automate your environment. I'm pretty sure that everyone's familiar with Puppet and everyone's familiar with Chef. I have no strong opinion about either one. We use Chef, but we use Ruby, so that's kind of why we did that. Combining something like this with the cloud, it's a very powerful pair. We can completely script every one of our kinds of machines. This is Redis, this is MySQL, this is Rails, this is whatever, and then it's just a case of start a machine up and have Chef run on it. We don't have to worry about repeatability. We can even write tests against it. Start an instance up. Does it do this? Does it have this on there? Never before have I been able to create an environment where I can test that my production machines are correct in CI. So we make a change to our recipe, the CI server starts up and it does the tests. It's great. You might not be familiar with this guy. It's really hard to tell because it's the Vagrant guy. This guy's a Vagrant. Who's using Vagrant? Okay, everybody has to go and check out Vagrant. This is definitely the best technology I have seen come out of anywhere for a long, long time. Essentially, it works on VirtualBox, which is the open source virtualization technology for your Mac or Windows or whatever, and it combines with Chef and Puppet to automate the creation of local development boxes. So in our environment, we run on Ubuntu in the cloud, and we have the ability to create an exact copy of all the different kinds of machines in roughly the same network layout inside VirtualBox using Vagrant. And it maybe takes 15 minutes to start up. That is something that 2 years ago I could not have conceived of. I always thought that virtual machines were for testing bugs in IE. Now I'm using them because I'm running on Mac, but we're deploying on Linux, so I've got Linux machines running in my VirtualBox, and all scripted via Vagrant. No need to keep doing the same things again and again and again. And the integration with Chef, for us, means that it's exactly the same recipes. It's not going in and apt-get installing a bunch of stuff each time we need to do something, or storing very carefully snapshots of these machines at each state, which was my previous usage of VirtualBox was, right, this Windows machine is working now. That is a very good milestone. Let's snapshot that, make some changes, snapshot that. You don't have to do that. You can automate everything. You can even automate Windows, which is great. So if you're taking away anything from this talk, it should be that VirtualBox and Vagrant is something that you need in your workflow. This was something that I dealt with for 6 years. Please, sir, can I have a machine? So when we sold SpringSource, I went to work for VMware, and I expected things to be great. VMware, they have virtualization software. Great. If I want a machine, it should be trivial. We'd been there for about 2 months, and we applied for like a big ESX box to run some of our tests on. I left 12 months later, still did not have that ESX box. I went back to the office the other day to visit the guys. They're still waiting for it. It's like 2 years down the line. This is at the company that makes ESX, and we couldn't get ESX to test on. It's crazy. And it is just this kind of pervading bureaucracy that you've got to request and very carefully specify what it is that you want on your machines. And we want Oracle, and it's got to be this version. With DevOps, you don't need to do that. The team's integrated. You can automate all that. You can work on it. You can iterate on it. I didn't realize how much I missed being able to iterate on my environment until I was able to do it. I was so used to being able to iterate on the code, write my tests, incrementally improve it, that was something I just craved for all the project. We tried to do that to our process. We tried to do that in our business. We weren't doing it in environments. And then when I finally got to that point where I could write a Chef recipe, test it on Vagrant locally, make some changes, test it again, run some tests against it, deploy it in the cloud and have it work, test it, test it, test it. And this was a day's worth of work to maybe build a whole environment. It was a real epiphany. No more, please, sir, can I have a machine. Get an infrastructure that allows you to do on-demand machine creation. As I say, DevOps has probably been the biggest revelation for me. I really like it. It's fun. I think that's another thing that's interesting as well, is it's like fun for developers to learn new stuff and branch out. I think people do not get into development as a job if you don't like learning new things. And I have definitely found this to be one of the most exciting things to get involved with, to learn, to develop my skills on. And as a startup, the development team is 2 guys, and the ops team is me. So it's great to have that integration, and it's just so much more practical now as a small team to do something big. You don't need to worry about having big data centers. By combining cloud and combining DevOps, you're getting big bang for your buck. You're putting one-time effort in and getting complete automation. We run 3 copies of our environment in AWS. It takes conservatively about 35 minutes to start the 6 machines, link them all together, start the database, create it from scratch, all that kind of stuff. 30 minutes. And now we're thinking, God, that's a long time. We've gone from 6 weeks being something we tolerated to 30 minutes being something we can't even bear. And our holy grail is that we want to treat most of that as disposable. Obviously, not all of it is. The database is still very, very, very important. You don't really want to be just throwing it away and doing backups and trusting that all the time. But certainly in machines, security rules, load balancers, all those kind of ephemeral things you can just chuck away and recreate as you need them. NoSQL. I really don't like this term. I don't like the name NoSQL because it kind of already assumes an implementation that there's going to be no SQL there. But SQL really isn't the thing people want to get away from here. And I think it's a bad name for a really good movement. To me, NoSQL is choice. It's allowing you to use the right tool for the right job. I think everybody now knows that relational databases are not the right tool for every job. I think we went through a phase where everybody thought the relational databases were the worst possible thing in the world. That seemed to be a lot of what I was hearing. That was a lot of the hype. And that all new systems should be built on MongoDB. But I think that's passed. And people are getting a little bit more perspective now and realizing that the right tool for the right job. And I think that attitude has been the biggest change in stack definition in the last 6 years, is it's no longer you must use Oracle and wedge your system into that. It's if Redis is the right choice for this particular problem, then we'll use Redis. And people are not afraid to use Redis and Oracle and Mongo together anymore. That has become acceptable. So what's in the name? Well, it's not NoSQL. It's really no relationals, no relations. And I think it's much better just to call this alternative data. How can we store our data in different ways? One of the really interesting approaches, I think, is document storage, so Couch and Mongo. And I know there's been a lot of backlash against Mongo recently, and obviously Couch went through some really strange project-level reorganizations. These are still good products, they're still motoring along, and they've still got a lot of potential. I think a lot of the problems have come from people believing the hype and applying these things kind of over-eagerly in areas where they're not suited. Document storage, I'm going to come back to the architecture in a minute because it's really interesting. Kind of key value stores, caches, that kind of thing. Memcache is probably really the pioneer here. Redis obviously is the big elephant in the room right now. Great products, but again, they've kind of been overused in the past and they really have like a little niche that they fit into. Some more obscure ones, Neo4j, anyone using that? Graph database in Java. Very, very targeted to a particular problem space. Why would people want to use something like this? Why not just use a relational database? Well, my view, in all honesty, is that your default should be to use the relational database. It's kind of a known entity. We're using MySQL for our system, and we do use it for pretty much everything because we know it, it's easy to operate, it's easy to back up, all of those things that are really important, it's easy to do. Performance is definitely sufficient. Some people are doing some really exciting and interesting things with MySQL. FriendFeed made their own document store on top of MySQL, which was basically just an ID column and a blob storing JSON. And they speak very highly of it and really love what they did with that. They were building some simple secondary indexes themselves, but for them, MySQL was predictable, a known entity, easy to engineer. Obviously, it's got years and years of backing behind it. And I think this is one of the interesting things, is the main benefit that people seem to focus on with NoSQL is performance. It's faster. It's faster. Well, that's not always the case, and it's not always important. I think the main benefit for using a NoSQL data store has got to be, does it fit the particular use case better? Is it an easier solution? Don't worry about the performance right away. Is it easier to solve my problem with? So document databases, for example, one of their interesting kind of features is that they're schemaless. So you can very easily change the schema of your data. We do loan applications processing and credit checking, and for different products, the set of data you need to capture changes. So a document store is a great fit for that because we don't need to predefine a schema that has all possible fields that we could ever want to capture, and we don't have to do big-scale database migrations and things like that. We can just migrate the schema dynamically as we go through it. Things like Redis have really good behavior for sort of transient data or things that you're not necessarily all that bothered about keeping. Not great for long-term persistence, but great for maybe session storage or kind of transient like cart data or whatever. And that's the key thing, I think, with NoSQL, is thinking about what are the use cases? Where should I be using these things? Why should I be using them? Not just thinking, oh, well, MySQL is slow and MongoDB is fast. Let's just use MongoDB. And don't be afraid to use a mixture. In our architecture, we use MySQL and Redis. We use Redis for job queuing, Redis for session storage. We have a little bit of session storage we share between some machines. We use Redis for search data. We index some of our stuff in Redis, and a bunch of other kind of things where rebuilding the data or losing the data is unimportant. So we don't even treat those relational machines as special. We don't back them up or anything like that. They're just there. Our intention is to move to using Mongo or something similar for our application front end, because that data is so variable and changes so frequently that the schemaless aspect brings a great benefit to us. But at the back end, once you've got a loan, all loans look the same once they're being serviced and run through their account. So there's no need to have something that schemaless there. And actually, the transactional nature of MySQL then serves a great benefit when you're recording payments and so on and so forth. So we want that at the back end. And that's been my interesting revelation, has been this real desire and this real comfort with using a mix of products. There's no longer one big database in your data tier. Your data tier can be 6 or 7 different products for the right job. So I'm very, very happy with that and very comfortable with doing that. Moving on to the final thing that I think is important, and I guess is kind of evidenced by this conference, is the emergence of polyglot programming. Get my words out. I think 3 or 4 years ago, a conference like this would have been very niche. And I look around today, there's quite a lot of people here. There's obviously a lot of people from the city. And polyglot has really become acceptable now. And I think it happened a lot earlier than people realized, and it happened because of JavaScript. 7 years ago, JavaScript was definitely hated by almost all developers. It was something you went onto the internet and you found a snippet of code that you cut and paste and include that in your system, and then tried to make it work with IE and Firefox at the same time. It's not that now. It's a serious language. People are using it for serious problem solving. Obviously, there's a big movement for people to use it on the server side with Node.js. I have no idea where that's going to go. Some people seem to like it, some people seem to hate it. But it's fair to say that JavaScript has become the language of the web. It is the language that is kind of pervading all the browser applications. And with the move to much richer front-end applications in the browser using kind of AJAX calls away from simple postback, JavaScript is getting a real resurgence. And it's become a skill that developers need to have now. You need to be able to code in JavaScript. You need to be able to understand it. And there's been a lot more work done on rationalizing the model, understanding the model, because it is a strange language, but people start to understand it. And for that reason alone, I would say that most web applications are polyglot. Even if you're wholly Java on the back end or wholly Ruby on the back end or whatever, chances are you've got a non-trivial amount of JavaScript code in your code base. That's certainly true for my application. It's mostly Ruby, but heavily JavaScript. Certainly for our internal systems, where we're taking a lot of advantage of a lot of the HTML5 features, we do a lot of JavaScript. But it's not just using two languages in two very different parts of your system. There's also a real push to writing discrete components of the same system in different languages. And one of the kind of key enablers for that has been this notion of the JVM language. It's a very big thing for Java right now, is that we have very, very good alternatives to Java that run on the JVM and integrate well with Java. Obviously, being here at this conference, I would say that Clojure and Scala are the two big ones. Scala certainly seems to be getting all the press right now. But Groovy has been doing this for years successfully and has got quite the large following. It couldn't be more different from Scala, I don't think, if it tried. But if you asked me 3 years ago whether I thought this was going to be the way it is, I would have said no. I thought, no, this can't continue to work. There's no backing. But now we've got companies like TypeSafe, which are backed by big VCs, and that's always a tipping point in my mind. If you think back to 2003, 2002, JBoss getting big VC funding, that was a real tipping point for open source Java when it became serious business. That's when you know there's going to be something in it because people are gambling money on it. And I think the same is happening here. That's a big organization. TypeSafe isn't just two guys messing around. They've got a lot of developers, a lot of money, and big ambitions. They've got a great board full of people who've done this before. So I think there's a big future for Scala. Whether you like the language or not, there's definitely a big future in that. And I think that then means there's a big future in JVM languages. And it doesn't have to be that you just write your entire system in Scala or your entire system in Clojure. You can mix and match. Beyond that, there are other languages that are getting great, I think really getting a lot of popularity. Erlang is a particular favorite of mine. Did a lot of work in Erlang when I was on the Rabbit team. It's a language that I really do love and miss when I'm not coding in it. It's got some quirks, but it's a lovely language. Same for Haskell. I really do enjoy Haskell. And I think the attitude is that you can fit in the right language in the right place. Anyone use WhatsApp? Yeah. It's all right. It's a chat app for the Android or iOS or whatever. And the talk right now is they're going to be bought out by Facebook. They have something like 1 billion users, like something ridiculous. And their server backend is all Erlang, and I think their front end is Ruby. And likewise, Twitter, a lot of front-end stuff in Ruby, a lot of back-end stuff in Java. This notion of mixing and matching the right language for the right job is definitely being taken on board by a lot of people. For us, Haskell's on our radar. We have the RISC engine that we've written. The first prototype was in Ruby, very quick, very easy to do. It's very hard to ensure the correctness of something that critical with Ruby, whereas with Haskell, we can build a lot of the rule checking and a lot of the correctness into the types. So we're going to look to move to that in the future. I'm really surprised by the resurgence of other languages, like R in particular. Like, does anyone go on Stack Overflow frequently? Like, I do haunt Stack Overflow a lot more than I should in phases. And I'm just constantly surprised at the large number of R questions coming in there. And it's something that's really become apparent to me because we're doing this loan business now and this finance business. There's a lot of statistical analysis going on, so we've hired some guys who do this kind of thing. I've got very little exposure to it, but I kind of thought it was dead. And now it's not. It's like massive again. It's great. Obviously, Google Go, like these kind of, what I'm calling them niche languages, which is probably a bit disingenuous, but they've not got massive exposure right now, but they're getting more and more people are writing specific bits in that language. Recently, somebody built this thing for Ruby called something to do with Norse gods, and the name has escaped me. Anyway, this cool little thing that was like a Rails pre-booter. So Rails is long, it takes a long time to start up, like horrendously long time. So they built this pre-booter so that you can like just restart just your application inside Rails. I thought that was really good, but they wrote that in Go. So it pre-boots Ruby, but it's written in Go. So it's really interesting to see that they've done that. And obviously I had to include Go because this is by far the best programming language logo I've ever seen. I was on like Google searching for logos for all these things, and I did, Golang logo. That came up, and I just thought, absolutely not. That is not the logo. And so it is. Brilliant. There are two main technologies that I think are enabling this move to polyglot, beyond just the existence of these languages and their tools. Obviously, that's required. But what's really required is a good way to integrate between Java and Haskell, or Ruby and Haskell, or whatever. You need a good way to do that. A lot of people have experimented, I think, with like in-VM calls. There is a Ruby thing that allows you to call out to Haskell and like in the same process. It's kind of a stagnated project, and I'm not sure that that's the right way to do it. On the JVM languages, that will probably work, but I still don't think it's the best way. The best way, I think, is to build discrete components in discrete languages and wire them together somehow. And a favorite way of doing that is REST. REST has really become a big thing. It seems that you can't be a startup now without having a REST API, even if you don't need one. It's just kind of like a rite of passage to have a REST API. But it does mean that it's very easy for systems in disparate languages to communicate, because HTTP is supported everywhere. It seems that JSON is supported everywhere now, so you've got a very simple, very easy to understand interop language there. But REST isn't perfect for everything, and that is where I think messaging fits in. And the messaging landscape has really changed, really changed. 5 years ago, it was JMS, TIBCO, whatever. Now there's so much choice. There's RabbitMQ, which is broker-based, very kind of ostensibly traditional, but has much more flexible routing, is fully open source. You can dive in there and deal with it. It's got all the HA features you need, which is great. But then there's something like ZeroMQ, which is completely different, like sockets on steroids. And you can choose what's right for your application and mix and match. We use RabbitMQ, and I was on the Rabbit team, so it's easy for me to do that. Some people think, well, ZeroMQ is easier. It's kind of easier for me to get started with. The key thing is that your stack can be now composed of all these disparate components in different languages communicating over messaging or REST. So why is all this exciting? Why does this even matter? Well, the most important reason that this is important, that this matters to you, is because you can use the right tool for the right job. You don't have to be happy with this cookie-cutter, all Java, Oracle stack, or all C#, SQL Server stack, or all Python and MySQL stack. You can do basically what you think is right, and you can use the right tool for the job. And that has become an acceptable and practical approach now. Not saying that necessarily your organization will be happy with that now, but in 2 years' time, it won't be something that people think twice about. It will be the norm. I remember when we were starting out at SpringSource, it was very hard to get open source Java into large organizations. Just very, very difficult. I went back to see some friends at the bank the other day. They're using Groovy now. They just made that decision on their own. There was no one there to sell it to them or no one there to shepherd them through it. They just went online, downloaded Groovy, got Grails going, got the whole thing going. The mindset has completely changed. There's no longer those massive, I don't know if anyone's been involved with this, these dead long processes where an open source product goes through this approval cycle. I shepherded open source projects through those processes at banks hundreds of times, and they were painful. It doesn't happen that way anymore. It's acceptable to use open source. It's going to be the same with this. It's going to be acceptable to use Redis, acceptable to use Scala and Java, acceptable to use Haskell and Java. People are going to change that. Infrastructure on demand definitely rocks. It's been the biggest change in my life, has been able to get machines when I want them, get databases when I want them, configure firewalls via an API. All those things are great. Scripting all that, automating all that, it's liberating. I don't have to worry about calling Rackspace and saying, please, can you reboot my machine? Do it myself. And embrace polyglot, if only for your own sanity and only for your own enjoyment. It's boring working in one language all the time. It really is. I enjoy working in multiple languages. There's definitely some issues with the grammar, like I occasionally write Java code and put commas at the end because I've been writing so much Erlang code that I forget what the correct punctuation is. But it's like speaking multiple languages in the real world. You get used to it. And all these things will enable you to build systems faster, build them more enjoyably, which I think is a very important part of software development. In developers who are having fun are doing better work. I've seen that time and time again over the last 13 years. And you can use the right tool for the right job. Did I time that just right?
We are just in time. Thank you. We have like 2 minutes for questions. Any questions, please?
Yes.
I hate these things. I work for one of these really boring corporates, and when I saw your beginning of your slide, I could have cried because I've got exactly the same problems you have. But a couple of things, because I work for a boring corporate, is how are you managing things like auditors? If you've got all these cloud instances popping up, coming down, and where your data may or may not be, how are you finding auditors are dealing with
Sure.
this?
So we have exactly the same problem because we're holding financial information. We have to deal with auditing. The first thing we did was make sure the cloud provider we chose was certified for all the relevant things that we needed. Handily, Amazon is a class 1 data center, so they were certified, and that removes a lot of the worry already. You need to choose a vendor who has the right locality for you. So Amazon was flexible for us because we could put the data in Ireland, not worry about US. For our business, US would be difficult, which is why we didn't look at Joyent and other people like that who only had US data centers. But then beyond that, it's much the same as everything else. Documentation, processes, all that kind of stuff. And in actual fact, because so much of it is scripted, it becomes a lot easier because there's no way in our process for an environment to diverge from the script. People are not allowed to do that. It's kind of banned. And all the same things apply. We have all the same tracking tools, all the same auditing tools, logging, everything, because it's just a machine. It's just about making sure that you're not hobbled from day one by choosing a vendor who can't be PCI compliant in our case, or who can't be DPA compliant. You've got to get that right. And then the main thing that we're doing for data is encrypting all the things that are sensitive, because we don't want them. Even if they're in Amazon and we trust them, we're encrypting it anyway. And you would do that as in your own data center anyway, but it's a bit more important, I think, when you're sending data out. And for data at rest in things like S3, we're encrypting that with public key encryption, and we keep the private key elsewhere so that there's no chance of that happening. We've not found it too bad so far. It's just about making sure that when you start, you choose the right vendor from the day one. The worst thing to do for us would have been to choose a cloud vendor, get all set up, and then realize that they weren't going to pass PCI audit, and then we'd be stumped. Does that answer your question? Any more questions?
All right. Thank you very much.
Thank you very much.